Okay, Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Wassalatu wassalamu ala asyrafil anbiya'i wa mursalin wa ala alihi wa sahbihi ajma'in. Assalamualaikum warahmatullahi wabarakatuh. We open this session with Al-Fatihah. Okay. How are you today? Is it okay?
Okay, madam.
Okay.
madam.
Have you watched the previous two videos I uploaded? One about OBE briefing, and another one is the lesson plan briefing. So if you don't do so, please do that, because I have explained especially about the lesson plan. So this is week number 2. So according to the lesson plan, so for the first chapter, you are going to learn moment distribution method. And in moment distribution method, you will be given assignment, 30% assignment, and I have actually divided into 3. So for the assignment or summative, there are 3 questions of summative assessment or assignment. So I will give you 3 times. So summative 1.1 will be given by this week, about 5% marks, and then followed by 10% summative 1.2 will be given to you by next week. And for the third one, 1.3 frame with side sway, I will give to you in week number 4. Okay. So just now what you watch is actually the recording, the recording video about the introduction on the moment distribution method, the one that I have uh, given lecture yesterday. Okay, are you from diploma or matriculation?
Diploma.
So there's no other matriculation, means that this is new to you, because for ex diploma students, so moment distribution method actually students have learned this. Okay, the basic about the beam analysis, diploma student have to take. Okay, so this is just like to revise back what you have learned previously, to enhance your understanding. But for those who are new, you come from matriculation, so this is new topic for you. Okay, this is new topic. Anyway, don't worry, because this is very famous topic in the world, moment distribution method. So there are so many videos in the YouTube channel you can find. You just type moment distribution method, as well as notes. There are many notes, e-books, okay, lecture notes shared by others. Okay, shared by others, and you can find it as well. So the textbook we use for this course is Hibler, under Hibler. The writer is R.C. Hibler. Okay, and I have actually put this ebook. Okay, I have picked up this chapter, and I have put in the class notebook. For those who are not familiar with class notebook, I introduce a little bit. Okay, so yang ni. So this is your teams, right? This is your teams. Okay, this is your team. So I have actually created, okay, your class notebook under this. Okay, under this teams. Okay, so under class notebook, you may find under teams. Okay, under teams CS 521 20222, you can find class notebook here. And class notebook is actually OneNote. Okay, OneNote. So if you use handphone, you have to install OneNote in your handphone. OneNote. Okay, OneNote in your handphone. Uh, uh, And if you use computer, doesn't matter. You can do it. You can open using browser. But it's good if you also install OneNote for Windows 10, like what I have right now. Okay, this is OneNote for Windows 10. You can download it. If you use computer, you can download it using Microsoft Store. Find OneNote for Windows 10. If you use handphone, you can also find this OneNote. Okay, then because I have added you into class notebook, then you will find that you have been added into this class notebook. Okay, this is all. Okay, under class notebook, you can find the textbook and the class note. Okay, I will add time by time. So under content library, okay, under content library, wait, I show to you bigger. Okay, so under okay, under please look at the content library in your OneNote, the content library. So under content library, you can find, okay, the textbook I have actually put inside. Okay, I just pick two topics. Actually, under the textbook, the moment distribution method, have I record my session? Done. Okay.
Yes, ma'am.
Okay. Okay, under the textbook, moment distribution method is actually chapter number 12. And I have also put here chapter 11, which is called as slope deflection method or slope deflection equation. Okay, this is actually okay, the continuation means that under the textbook, slope deflection method or slope deflection equation is the chapter, chapter number 11, followed by chapter number 12, moment distribution method. And chapter number 12, moment distribution method, is a continuation to slope deflection method. So some of the theory, principle, concept that has been discussed under slope deflection method, okay, does not repeat, okay, in the moment distribution method chapter number 12. So that is why I put here, because there are some principles, some concepts, some diagram that you have to refer to this chapter as well in order for you to understand what is actually moment distribution method. Because dulu last 10 years under this course, slope deflection method as well as moment distribution method, student need to take both these two methods. But this time slope deflection method has been removed, but again, the theory, the principles, you need to still to refer to this chapter, slope deflection method. Okay, slope deflection method. Basically, both method, okay, both method have same outcomes. Same outcomes means that in moment distribution method, we will calculate member and moment. Also, uh, in slope deflection method, when we analyze structure using slope deflection method, also we calculate member and moment. Okay, the same thing. The output will be the same, member and moment. So actually, the free body diagram to understand more about indeterminate beam, indeterminate frame that we are going to analyze in moment distribution method. So some of the diagram, so actually has been discussed under slope deflection method. That is why I put here. So feel free to read this as well, even though you cannot understand all, doesn't matter. So just read. And of course, this is not the only material that you can refer. Okay, as I mentioned, there are so many videos, and under my channel as well, I have actually put videos, have videos regarding this topic since 2017. Okay, so you can also watch that, and then find also uh, material, other material which come from other lecturers maybe. Okay, and the class notes. Okay, I have also put here the slide. Okay, And the slide as well, is just the summary of the textbook. So the main reference is always the textbook. The main reference is always the textbook. And of course, I will also pick some question from previous past year's exam papers to be discussed. Maybe not in class. I will also do extra session live streaming in YouTube. So you are invited to join if you free at that particular time. Okay. So referring back to this note, so the outcome, I believe for those who join, I actually play the video from the recording video just now from my handphone, because at 10 kan, jalan jam teruk juga jalan dekat area from my home. I live in Kepala Batas, Bertam. Okay, so along the way hantar anak sekolah, lepas tu jalan highway jam. Kat depan ni pun jam teruk. So that's why saya play siap-siap video tu so that you boleh tengok dululah. Okay, so the most important thing I always told my student, when you take this course, this is indeterminate structures. Actually, kat sini you need to actually enhance your understanding in structural analysis, because you have learned this previously. You have learned this you have learned this in solid mechanic. You have learned it in solid mechanic. You have learned this in determinate structure, CS424. So all is previous that you have learned is all about determinate structure. So this is just the continuation. This is indeterminate structures. And again, in structural analysis, there are only three things that you need to do in summary. Okay, number one, when you have the structures, when you have any type of structures, you have to calculate reaction. That is number one. Number two, number two is internal forces. And number three is displacement. So I always told my student, if anybody outside, okay, not in this field, asking you what do you learn? What do you learn in structural analysis? So you should be able to tell them that in simple word, in structural analysis, I learn how to calculate reaction. Okay, reactions. Number two, I learn how to calculate internal forces. Number three, I learned how to calculate displacement or deformation. This is all. Okay, this is all that you learn in structural analysis. Of course, under this, you have to know the support system. Okay, you have to know what is actually free body diagram, about the loading, and the output that we calculate. Okay, that we calculate is always these three things. So under beam analysis, for example, when we apply equilibrium equation, we analyze reaction, right, at the support. Okay, and then to calculate the moment in beam. Okay, dah belajar ni kan, beam. Okay, this is cantilever beam, right? Cantilever beam like this.
Madam,
Ya?
skrin madam tak bergerak.
Oh, screen tak bergerak. Kejap. Saya check balik. So tolong bagi tahu apa yang tak clear dekat screen. Sekarang nampak tak my screen? Sekarang nampak
tak madam. Dia dekat learning outcomes dari tadi.
Oh ya ke? Kejap. Saya nampak lah. Kejap. Kena bagi tahu tu. You have to tell me apa you nampak dekat screen. Sekejap, saya open lagi satu. Sekarang nampak apa dekat skrin?
Saya masih nampak learning outcomes.
Sama kat
Saya
madam.
nampak.
Kejap. Pelik pula kejap. Patutnya sekarang ni saya on screen. Tak nampak saya Saya seorang on screen, tak nampak?
Freeze. Dia punya muka freeze.
Freeze. Sekejap saya list, saya masuk balik. Kita try Sekejap Sekarang nampak apa sekarang ni?
Nampak madam.
Nampak saya. Kalau yang ni?
Nampak skrin madam.
Nampak skrin Okay, yang saya gerak-gerakkan ni nampak tak?
Nampak.
Okay. So screen masih recording kan? Okay. So kalau nampak pelik bagi tahu Okay. So saya kat sini dekat reaction ni. So in structural analysis and whether it is the determinate structure or indeterminate structure, so actually we can summarize the output. Okay, with these three things. Okay, number one is reaction, number two is internal forces, number three is displacement. Three things. So as I mentioned just now, so if anybody outside engineering field asking you what do you learn actually in structural analysis, so this is the answer. Okay, in structural analysis I learned how to calculate reaction. Okay, number one. Number two, I learned how to calculate internal forces. Number three, I learned how to calculate displacement. This is why for those who are coming from diploma, masa you buat project guna SIM tu kan? Okay, using software, when you analyze structure using software, so the output that we can get from the software, okay, are these three things. Number one, reaction. Number two is internal forces. Number three is displacement. Okay, displacement. This displacement is actually the behavior. This is behavior. This is behavior of the structure. Displacement. So displacement is very, very important. Analysis is very, very important because without analysis, you cannot do design, because in structure we will have analysis and design, and without understanding structural analysis we cannot do design. And under design, of course, we will refer to standard. Okay, we refer to Eurocode. Okay, so under design, okay, there will be okay, displacement will be the one of the criteria that you need to consider whenever you want to, for example, design or model the building. To know whether the building is safe, to know whether the building, the building, we can proceed with the model. Okay, of course, inside the standard tu, dia ada clause dalam standard yang mention displacement cannot exceed certain value. Means that this is displacement. Of course, under design you have to consider the real condition, and in analysis, the difference is in analysis we simplify the things. Okay, that's why simplified the things. That's why we can just calculate by using equilibrium equation. That is all the limitation that we made. Actually, in real things, not only this thing that we study is actually based on some limitation. So in structure, actually we have static, we have dynamic. Okay, we have static, we have dynamic, and the basic comes with static analysis. So this is static analysis. So there are some principle for static analysis, some limitation that have been made for static analysis. Especially, we can calculate, we can apply equilibrium equation, total mx0, total fx0, total fy0. That is one of the limitation. And then another limitation is come from you have learned this from yang learn diploma, and yang mana yang dah buat lab juga. It is come from modulus yang tu, modulus of elasticity. So dia ada dalam graf ni. Okay, bila you buat tensile test, for example, for yang diploma lah, nanti yang degree matriculation mungkin you akan buat di semester kot, lab kan next semester. Okay, so ada graf ni. So graf ni dia ada sini, dia punya yield point, if you remember. Yield point kan? Yield point. So dekat sini nama dia kan, dekat sini nama dia static. Ini static. Static range. And under static range ni, dekat sini static range ni, this gradient is E. So inilah kita punya E tu. E, modulus of elasticity. So this graph is versus strain. You remember this? Okay, that's why we get E. So yang ni static analysis. Static analysis. So yang kita discuss dalam degree level ni so far hanya static analysis. And static analysis tu lah yang kita apply equilibrium equation, lepas tu static, lepas tu ada E, that we need to consider whenever we calculate displacement, kita ada include E, and then K as well lah. So this graph as well, if we draw P versus displacement, so we get the same graph. So this is the yield point. So this will be the K. Okay, this one is K. So what is K? K is stiffness. So dia akan relate dengan stiffness. So displacement. Okay, displacement yang you calculate last semester under unit load method kan, if you realize dalam formula tu dia ada E, dia ada I. So I ni dia relate dengan K. Okay, semua tu akan give effect for the displacement. Okay, so again this time we will continue, but we continue with analysis of indeterminate structures. Okay, indeterminate structures. So we will calculate also reaction internal forces and displacement. And for moment distribution method, the member and moment in moment distribution method is actually this. Internal forces. Okay, the output in moment distribution method. The output in moment distribution method is actually internal forces. It is moment. It is bending moment. Okay, the moment that we will calculate. Okay, the member and moment that we will calculate as the output of moment distribution method is actually internal forces. Okay, internal forces. After we determine the member and moment, then we have to calculate, okay, remaining reaction, and we don't calculate displacement in moment distribution method. Okay, we don't calculate displacement. So this topic, we will concentrate on member and moment, internal forces, and using internal forces, we will calculate remaining reactions, means the shear force or the vertical forces at support. Okay, so nota ni, sama ada textbook ataupun nota slide ni, I believe you can read on your own. Okay, if you have any question, please ask. So saya takkan follow one by one apa yang ada dalam notes. Okay, apa yang ada dalam notes. So saya akan highlight and focus important things and what is actually needed for you to answer assessment lah, summative and formative assessment. Okay, so under this, nampak learning outcome sekarang ni? Nampak?
Nampak.
Okay, learning outcome, so nampak tak kat sini? Dia kan kat sini semua dia cerita proses. So you have to know stiffness. Tadi dalam graph tadi saya tunjuk stiffness kan. What is stiffness? Okay, distribution factor, DF distribution factor. So we use DF label in the table. Okay, carry over factor, the factor that we use to distribute moment. Ni carry over factor ni COF ya. CO ni CO. Okay, carry over. So carry over factor ni we use this factor to distribute moment. Okay, stiffness modification factor ni kita tak touch in detail lah. Okay, fixed end moment. So another things that you need to understand, fixed end moment. Fixed end moment, there are two conditions. One is due to external loading. This is number one. External loading. Number two is support settlement. For this week, we focus on external loading. External loading first. For next week, only we discuss support settlement. Okay. So this is the coverage. Yang ni you dah tengok tadi kan dalam video. Coverage kita beam and frame only. Beam and frame only. Okay. General principle and definition ni. This is just to explain you the procedures, because moment distribution method ni very easy to apply because we can formulate this into Excel and then we can get the moment directly. Cuma process tu you have to know first lah to understand. Okay, so the process. Okay, tengok yang saya highlight tu. The method begin by assuming each joint is fixed. So yang ni assuming ni relate dengan fixed end moment tadi tu. Okay, that is why even though we have continuous beam, fixed, roller fixed kan, internal tu fixed, tapi we have to assume all fixed. That is why we can apply fixed end moment formula for all members. Okay, and then by unlocking and locking each joint, internal moment. Okay, internal forces kan right now, just now kan. Okay, so we focus on internal moment lah. Internal moment at joint distribute. And balance until the joint have rotated to their final nearly position. Okay, proses dalam moment distribution method ni apa kita nak buat is we will calculate internal forces which is called as member and internal moment which is called as member and moment. Cara dia kita akan distribute moment. Macam mana nak distribute moment tu? Kita kena kali dengan factor. Kita kena kali dengan factor. So kita akan repeat the same process again and again until the moment reaches zero value. So ni principle dia. Okay, yang ni tadi yang relate dengan fixed end moment. Okay, lepas tu kita nak akan distribute and balance, and this process is repetitive and easy to apply. Okay, so about sign convention. So sign convention for moment distribution method suggested by Hibbeler is clockwise. Okay, so I mentioned about Hibbeler because if you refer to maybe another reference, maybe another text, another reference book, other book may have different direction. For example, Aslam Kasim Ali. Okay, buku ni ada kat library. Aslam Kasim Ali. Saya pun ada dia punya soft copy. Kalau you nak, you bagi tahu. Okay, Aslam Kasim Ali pun ada buku structure analysis and moment distribution method as well as slope deflection method in Aslam Kasim Ali book. Okay, use counterclockwise as positive. So you may if you refer to, for example, notes from internet kan, you may find example ke kan, tapi yang sign dia semua terbalik. Sebab apa sign dia semua terbalik? Sebab assumption yang dia buat at first ni, at the beginning ni, dia punya counter clockwise. So yang kita follow is Hibbeler. Yang kita follow ni Hibbeler. So Hibbeler kata pakai clockwise positive. So we use clockwise positive. Clockwise positive. What does it mean? Yang ni yang saya ada mention dalam video tadi. Kalau you ada tengok tadi, kat mana Sampai situ tak tadi? Oh, saya mention dekat dalam textbook, Tadi ada tengok sampai situ tak? sampai fix and moment punya direction, member and moment direction. Ada tak tadi? Kat sini ya. Kat sini. Kat sini. Tadi ada tengok sampai kat sini tak?
Ada, madam.
Ada. Ada. Okay, so yang ni saya tak nak repeat detail lagi. Okay, cuma yang tadi tu sign convention mention clockwise positive tu kan, referring to the member and moment. Means that yang color orange ni lah, color orange. Yang color orange ni adalah sign convention mention just now. Means that each member at the beginning we assume clockwise. Okay, sign convention clockwise tu referring to yang color orange, member and moment. Okay, this is the first assumption. Of course, nanti after calculation kita akan dapat the real value. Some may be positive, some may be negative because it depend on loading. Okay, but this is the beginning of analysis. We have to set in mind clockwise is positive for member. Clockwise is positive for member. So that's why dalam ni you nampak kat sini ada color orange, ada color hitam. Okay, so yang color orange tu is member and moment. Okay, member and moment clockwise positive. Clockwise, all clockwise. Okay, all clockwise. And beside the orange, there is also the moment arrow yang color black. Okay, moment arrow yang color black ni referring to join moment. So beside member and moment, we also have join moment. Member and moment, and then beside that we have join moment. Yang ni saya sketch, saya dah pisahkan lah. Means that this is the free body diagram. Okay, free body diagram from the diagram on top of that. Okay, the diagram tu, the continuous beam A, B, C, D. Lepas tu ada UDL along BC tu. So if I draw the free body diagram, I draw free body diagrams. That's how it's look like. Okay, so we draw element by element. Start from member AB, member BC, member CD, and then for these members we have 6. Warna hijau tu lah 1, 2, 3, 4, 5, 6 tu. 1, 2, 3, 4, 5, 6 tu yang bawah tu lah MAB, MBA, MAB, MBA, and then 3, 4 tu MBC, MCB, and then 5, 6 tu MCD, MDC. So what is actually member and moment? So yang 66 ni lah. So 66 ni lah dia member and moment. Okay, member and moment. Means that kalau soalan minta you calculate member and moment, nak calculate apa? Calculate 66 ni. Okay, so each member has 2N. Each member has 2N and each N ada moment. So that moment is called as member and moment. And please also remember, beside member, we also have join. We also have join. So join moment is opposite with member and moment. Join moment opposite with member and moment. Opposite. Nampak tak? Yang hitam tu dengan yang orange tu, yang orange tu clockwise, yang hitam tu anti-clockwise, counter-clockwise. Nampak tak? Yang hitam. Yang arrow warna hitam.
Nampak.
Okay, so yang arrow warna hitam tu, okay, is referring to join. Okay, join, nama dia join moment. And join moment opposite with member and moment. Dalam buku teks, under topik number 12, moment distribution method, tak ada diagram tunjuk full macam ni. Okay, join ni dah sebut dalam slope deflection method. That is why saya letak slope deflection method tu. Okay, kalau you nak tengok dalam buku teks kat mana dia bincang tentang join moment yang counterclockwise macam ni, refer chapter number 11. Okay, so siapa-siapa yang from diploma, do you remember, bila you distribute moment, kan kita kali dengan distribution factor, you change sign. Siapa yang remember this step? Siapa yang still remember this step? Bila kita distribute moment, kita akan totalkan moment and then kita kali dengan distribution factor. Lepas tu, sebelum kita letak value tu dalam kotak dia tu kan, kita akan change sign. Siapa yang still remember this process? Ada tak yang still remember this? Anybody? Ke dah lupa semua? Do you still remember moment distribution method? Dah belajar bila? 2 tahun lepas, 3 tahun lepas? Ke dah lupa?
Lupa madam.
Dah lupa dah. Okay. So yang mana yang ingat tu kan dulu masa belajar masa diploma. So masa diploma tu mungkin at that time your lecturer tak explain the concept. So kenapa kita change sign? Okay, so that is the beauty of structural analysis because negative positive tu dia can be representing by diagram. So dia ada reason to justify why we change sign. Kan why we change sign? That is dia mesti ada reason. Dia tak boleh kata okay change sign yang ni total kali ni change sign letak jawapan. Dia bukan macam tu proses dia. Dia change sign tu with reason. So what is the reason? Because the moment that we distribute is join moment, not member and moment. Member and moment dengan join moment, condition dia terbalik. Condition dia opposite. So whatever moment that you get, lepas you tambah dua-dua moment dekat join tu, kan? Yang tu adalah member and moment. Tapi to represent join moment, kita kena change sign because condition dia opposite. That's why kita letak negatif tu. So kalau you dapat negatif, letak positif. Dapat positif, letak negatif. To represent join moment. That is actually the real thing occur whenever we want to distribute moment. Ni konsep-konsep dia. So yang those yang very new tak faham lagi tak apa. So dengar dulu the term-term important term yang saya sebut, nanti bila kita move to example you akan faham. Okay, so yang ni ini dia member and moment, the internal moment yang 6 ni kalau ada 4 element dia akan jadi 8. Sebab 3 element ada 6 sebab 1 element or 1 member ada 2n. Ada 2n. So dua-dua n tu akan ada moment. Akan ada moment. So that's why dalam tadi the explanation yang first tadi tu dia ada sebut kita assume semua fix. Sebab fix baru ada moment. Kalau kita dah gabung dia jadi kosong. Dia akan jadi kosong pada MB kosong, MC kosong. So yang ni pun sama. MB sama dengan kosong ni dah explain dalam slope deflection method. Okay, MB ni equivalent to 0, MC equivalent to 0. Okay, so refer back to slide tadi. Okay, tadi sign convention kan? Tadi sign convention. Okay, tadi sign convention. Okay, so just remember clockwise positive. Clockwise positive, yang ni dimension about member. On the member, nampak tak ni? Member. Sini ya, member. Okay, member clockwise positive. Join moment, opposite. Join moment, opposite. Okay, join moment, opposite. Okay, move to fixed end moment. Fixed end moment. Yang ni pun semalam saya dah explain quite detail. Fixed end moment. Kejap. Okay, apa yang nampak kat skrin?
Nampak skrin madam.
Okay, nampak fixed end moment Okay, so fixed end moment. Yang ni satu lagi yang nak kena clearkan. Fixed end moment. Kalau tadi sign convention for MDM. Sign convention for MDM as suggested by the author of the textbook Hibler, dia pakai clockwise positive. And I also told you that we have another reference book written by Aslam Kasim Ali yang pakai counterclockwise positive. Means that sign convention yang tu okay boleh can be clockwise, can be counterclockwise. Means that boleh assume. Tapi kita akan follow satu lah, kita akan follow Hibler. Sama juga macam kita nak calculate reaction, for example. Kita nak calculate reaction, we apply equilibrium equation. When we apply equilibrium equation tu, moment tu kita boleh take clockwise or take anti-clockwise. Sebab dia assumption. Tapi assumption ni dia mesti constant lah. Dia tak boleh sekejap negatif, sekejap counterclockwise, sekejap clockwise. Tak boleh. Dia mesti constant. So kalau kita dah decide, okay, we we follow Hibbeler as our main reference, the textbook. So we have to follow clockwise positive. But fixed end moment ni bukan assumption. Fixed end moment is not assumption. Fixed end moment ni is behavior. Fixed end moment is behavior. Okay, behavior. Fixed end moment. So dalam buku memang dah ada lah yang ni, kalau you tengok dalam textbook. Nanti saya akan letak juga this sheet, the full from textbook for the formula fixed end moment. Fixed end moment. So yang ni behavior. Behavior. Nampak tak? Dia behavior. Yang ini pun I have actually explain semalam dalam video yang tadi tu. You boleh tengok balik untuk lebih clear benda ni. So fixed end moment, dia behavior. Behavior maksudnya dia akan reflect to apa to load due to loading, dia akan reflect. Okay, that's why fixed end moment. So beam tu dia ada dua end, dia ada fixed end. So bila fixed end ni dia ada moment lah, bila fixed end dia ada moment. And moment tu kenapa dia macam ni? Nampak tak dekat diagram tu? Okay, so yang ni fixed end moment. Yang ini fixed end moment. Yang atas, nampak tak? Yang atas tu MDM sign convention. Okay, MDM sign convention. Yang bawah tu fixed end moment. Bila ada loading, okay, beam tu akan bend. Beam tu akan bend, dia jadi bengkok. Okay, bila dia bengkok, macam ni dia bend. Okay, so fixed end moment ni will react at both end to push back this point and this point so that the beam will move back to straight position. Dia mesti move balik. Bila kita apply moment is to push the beam back to straight position. Okay, that is the reason why we apply fixed end moment. So fixed end moment, when we apply, we want to remain equilibrium. Okay, the beam must remain equilibrium. So we put fixed end moment. We calculate the value. So the direction of fixed end moment is behavior. Behavior means that kalau you nak jadikan dia yang bawah tu, you nak apply moment arah mana? You kena apply moment arah ni hitam atau apply moment arah ni red. Is it red or black? The real behavior to make it straight.
Black.
Black. Okay, black. So that is fixed end moment. Means that fixed end moment ni bukan boleh assume je ya. Fixed end moment kena refer to the beam. Kita kena faham yang fixed end beam tu bila ada loading, okay, it will be bend. Okay, that's why when we have support, okay, support tu akan help the structure to remain equilibrium. Okay, to remain at same position. Same position. So how to remain straight? By applying moment, okay, applying moment to push back the beam to its original position. Sebab kalau warna hitam dia akan jadi straight. Kalau warna merah dia jadi apa? Kalau warna merah,
Jadi V.
ini means that
Red.
okay. So kena apply the right FEM, the right direction for FEM. So yang color hitam. That's why dalam formula ni, kita tengok yang the first column. Both and fixed ya. Kita tak tengok yang kolom yang kedua tu. Nampak tak? All moment semua arah macam tu. Okay, sebab dia reflect kepada beam punya behavior. Kan beam tu bend. So you nak push back beam to originals, to straight, to horizontal position, you kena apply moment in this direction. So that is why we will get one negative, one positive. And we put into the table because kita punya sign convention. Okay, sign convention MDM clockwise. Jadi yang dekat bawah ni, okay, yang dekat sini kan. Dekat sini, dua-dua ni dia opposite, right? Opposite. Can you see that? Yang bawah tu behavior, yang atas tu MDM set convention clockwise. So yang ni anti-clockwise, counter-clockwise. So this is negative because of the opposite condition. Okay, and another one yang ni lah, yang ni dua ni kan. Dua-dua tu same direction. That's why it is positive. Positive. Okay. So that's why yang MDM due to loading ni, is always like this, due to loading, because we have another one due to delta. Due to delta, behavior is different, so moment will be different. So yang ni saya tak repeat because saya dah explain quite detail dalam video tadi. So you tengok balik, I have explained why in the last formula, okay, due to delta, the fixed end moment is different. Okay, dah explain dalam video tadi. Okay, we move to member stiffness factor. Member stiffness factor. So in structures, stiffness is very important term. Stiffness. Okay, stiffness ni behavior dia stiff. Lawan dia flexible. Okay, lawan dia flexible. And stiffness ni is one of the important parameter that we need to consider in analysis and in design. Stiffness. Okay, stiffness. So for calculating distribution factor, we have to calculate the stiffness factor. Okay, the stiffness factor, the symbol used is K. The symbol used is K, the stiffness factor. So we have four condition. Okay, we use K equal to 4EI over L. Yang ni kita buat one by one member, one by one element. K equal to 4EI over L for far and fixed. Far and fixed. Nama dia far and fixed. So kenapa nama dia far and fixed? Dia macam ni tau. Okay, for example, we have this. Okay, 1, 2, 3. So we have A, B, C. A, B, C, D. Okay, the term used is far and fixed. Far and fixed. In this case, they refers to A and refers to D. Means that bila kita nak calculate K for AB, when we want to calculate K for AB, kita akan refer NA. So kita pakai 4EI over L. Okay. So when we want to calculate BC, KBC, BC internal always assume fixed. So internal we always get this. Okay. Always this. This is for internal. Okay. Internal 4EI over L, KBC ni. KBC 4EI over L. Yang ni always use 4 for internal. Okay, sebab internal forces we assume as fixed. And then CD, KCD. KCD. KCD far end refers to D. Far end refers to D because yang internal tu dah memang fixed kan. Okay, kita refers to D. So the D is fixed, so we use 4EI over L. Okay, we have another formula for far end roller, far end pin. Okay, the formula for that one is K equivalent to 3EI over L. 3EI over L yang ni. Okay, for this one, okay. Okay, yang ni 3EI over L, 3EI over L. Yang ni for, this is for far and pin. or roller. And pin or roller. Okay, pin or roller. So condition dia macam mana? Condition dia macam ni. Roller, roller, roller for example. Okay, so this is A, B, C, D. Okay, again, far end refers to A, far end refers to D. Because B dengan C fix, assume fix. So to calculate K for this beam, KAB, we use what? 4EI or 3EI?
4.
4EI over L. KBC, we use 4. Of course, internal we use 4. So what about CD?
3.
3EI over L. So it very simple, quite straightforward. This is how we calculate K. Okay. And then to calculate the distribution factor, the formula to calculate distribution factor yang ni. Okay, distribution factor. So distribution factor, we will use this factor to distribute moment. We will use this factor to distribute moment. How to calculate this? Okay, this is the formula K divided by total K. K divided by total K. So K is member stiffness. Total K is joint stiffness. Okay, K is member stiffness. Member stiffness. Total K means joint stiffness. Joint stiffness. And DF, okay, this DF ni, DF is always equivalent to 1 total. DF for joint. For joint, DF is always equivalent to 1. Okay, except, ada except except fixed end. Except fixed end. Except fixed end. Okay, means that kalau join tu ada, for example yang ni, contoh kan. Contoh beam tadi. Okay. Kita ambil yang ni lah, yang dua-dua fix ni. Okay, like this. A, B, C, and D. A, B, C, D. So, yang ni kan makna dia yang ni, except fixed end. Because fixed end distribution factor is equal to 0 for fixed. For fixed end. Means that distribution factor for A, for distribution factor for AB yang ni 0. Okay, for D also 0. For B, B distribution factor equal to 1. C equal to 1. But B and C ni dia come from 2. Okay, B dengan C come from 2. Come from BA, come from BC. Okay, distribution factor. It come from BA, BC. So we get DF from DF ni 1 ni means that we get from something. Okay, yang ni pun we get from something. Macam ni. So total tu yang dapat 1. Okay. So this is concept of distribution. You boleh tengok dekat sini. Concept how we get moment. For example, yang tadi tu yang ni yang ni. So yang ni K yang dia dah given value. K for element. Normally K ni kita akan calculate. Kita akan calculate using formula just now. Yang ni dia just nak tunjukkan the process. Okay. So when we apply moment and then moment ni kita akan kali dengan distribution factor ni lah. Distribution factor. Okay, distribution factor. So this refer to join tadilah. Join. Okay, join. Okay, so kita nak buat satu example so that you akan nampak lagi clear lah. Selagi tak buat example ni tak nampak clear. Masih lagi bayang-bayang je. Kejap. Okay, another thing I want to highlight is factor, carry over factor. Carry over factor ni kalau for carry over factor untuk n carry over factor is 0.5. Okay, for n fix, kecuali n pin. N pin equals to 0. Okay. Okay, kita tengok this example. So example ni is actually example 12.1 Hibbeler. Example 12.1 Hibbeler yang ni. Okay, determine internal moment. Internal moment means member and moment. So kat sini member and moment ya. Member and moment. This is member and moment. At each support of the beam shown. Okay, EI constant. So in this case, EI constant. Okay, step number 1, what should we do? Step number 1. Step number 1, to analyze this, step number 1, we have to calculate stiffness factor. We have to calculate stiffness factor. Okay, step number 1, calculate stiffness factor. Calculate stiffness factor, K, calculate K. Okay, how many K do we have in this beam? How many members in this beam? How many members?
3.
3 members. So this is member number 1, this is member number 2, this is member number 3. So we will have 3K. KAB, KBC, KCD. Okay, so this is the first step. We will calculate K1, okay, K1 or KAB, and then KBC, and then KC, KCD. Okay, KCD. So by looking at the diagram, A fixed, D also fixed. So each members we use 4EI over L. 4EI over L. So AB, BC, the length is 12 meter, CD 8 meter. Okay, so we can calculate KAB equal to 4 EI constant remain EI divided by 12. Okay, this is KAB. KBC, okay, also 4 EI over 12. If EI is not constant, we have to include here. And KCD, we use 4 EI over 8. Okay, this is quite straightforward, just like this. Okay, just like this. This is how we calculate K, stiffness factor. Stiffness factor. And then the next step that we should do is to calculate distribution factor. So we now calculate distribution factor. Calculate distribution factor. Calculate distribution factor. Distribution factor, okay, A and D because both are fixed. Okay, distribution factor. Okay, numbers of distribution factor must equal to numbers of member and moments. So if we have now we have now 3 members. One member has 2n. So total member and moments that we are going to determine are 6. 6. So 6, this 6, also we have to calculate 6 distribution factor. So distribution factor pun ada 6 jugalah. So number 1 distribution factor kita simplify as this symbol AB. AB means that NA. The first one tu yang hujung tu lah, refer to yang paling hujung tu. So yang ni distribution factor dia 0. Why we get 0? Because we divide by infinity. Okay, that is why we get 0. Formula dia sama juga. Formula untuk calculate yang ni. Calculate yang ni adalah KAB plus KAB plus infinity. That's why we get this as 0. So special case lah yang ni, kalau n dia fixed, means that 0. Means that fixed ni not the end of structure. Fixed is not the end of structure. Yang end of structure ni end cantilever, end pin, end roller. Yang tu memang end of structure. Tapi kalau dia fixed end, means that dia infinity. Dia banyak lagi lah. Okay, cuma kita just want to consider to analyze one beam out of 1,000 beam dalam structure tu. Okay, that's why sini letak infinity. So equal to 0. Equal to 0. So this is the FAB. So then the FBA lah. The FBA. The FBA. The FBA. The FBA. So dekat B tu, so look at back to the diagram. Okay, look at back to the diagram. At B, so at BK yang ada dekat sini 4EI over L over 12. Dengan satu lagi pun 4EI over 12. Okay, so dia connect to these two members kan. These two members. So to calculate K, bukan K, DFBA, kita kena ambil yang ni divide by total. Divide by total. Okay, yang tu DFBA. Okay, DFBA yang biru tu divide by total. Bila nak calculate DF, yang ni DFBA, kita ambil 4EI over 12. 4EI over 12 divide by total. Divide by total. So we get 0.5 yang ni. Okay, EI will be cancel and then dia sama value semua kan dapat 0.5. And then DFBC pula, DFBC equal to 1 minus 0.5 lah because tadi saya mention total must be 1. Okay, total must be 1 dekat B ni. DF dekat B ni total must be 1. 1 tu combination of DFBA, DFBC. Kalau kita nak calculate, kita calculate guna yang ni lah. Kita calculate guna yang ni. Yang ni. Divide by total, dapat balik 0.5. Okay, so kita dapat yang ni. Okay, this one, the formula is K. Tapi tak payah tulis formula in detail sangat. Yang ni kan, nanti buang masa kalau you tulis formula. Nanti kita akan buat in short way. Okay, so yang ni KAB, KBC. So this is equal to 0.5. And then DFBC is equal to 1 minus 0.5. We get 0.5 as well. So we calculate DFBC dah, DFCB pula. DFCB, again, DFCB tengok join B. Tengok pada join B. Okay, dekat join B ni. Okay, dekat join B. Okay, at join B. Okay, yang tadi nanti dah C. Okay, BA, BC dah tadi kan? Okay, yang ni at join C ni between BC dengan CD. Itu join C. Join C between BC and CD. So, to calculate distribution factor for CB, CD, we have to consider this value lah for EI over 12 dengan 4EI over 8. So guna this value in total, kena totalkan lah total K for C, totalkan yang tu yang bawah. So yang atas kita buat one by one lah. Okay, so we get like this. CB. Okay, it is 4 divide by 12 divide by berapa tu? 8. Totalkan kejap. Pakai calculator. Where is my calculator? Ini. Okay, so formula dia tu, nanti kita buat dalam Excel lah tak apa. Okay, yang ni formula dia tu KBC divide by C. KBC, BC plus KCD. So nanti kita akan dapat value ni. Sama juga DFCD. Then kita akan dapat this value DFDC equal to 0. So in summary, saya nak tunjuk in Excel how to calculate this easily. Okay, how to calculate this easily. So I will open Excel. Okay, nampak apa kat skrin? Nampak Okay. So we want to calculate distribution factor. We want to calculate distribution factor. Okay, we want to calculate distribution factor. Distribution factor. We can calculate distribution factor from stiffness factor. Okay. Stiffness factor. So how many member and moment? We have 6. So we have AB. We have AB. We have BA. We have BC. We have CB. CD as well as DC. So 6. Okay, representing each end. Member AB ada member AB ada ABBA, member BC, BCCB, member C CD, CDDC, CDDC. So this will be representing 6 member and moment. Later on, we will calculate this value. So in order to do that, we have to calculate stiffness factor. Stiffness factor. And stiffness is always for element. Always for member. Dia cannot be joined. Dia maksudnya yang ni as one member. As one value only. So K for this one is 4 divided by 8. 4 divided by 12 tadi. Okay, 4 divided by 12. It is 4 EI. EI constant. EI is constant like this. So KAB and KBA is actually the same value. The same value. Okay, same value. Okay, then for BC, CB, the same member, right? So this is also 4 divided by 12. So again, we get this. And then K for CD, CDDC is the same member. So don't get confused. Dua-dua ni same value. Okay, same value. So this is 4 divided by 8. Yang ni lah. So yang ni. Okay, take 3 decimal point. Okay, cannot be 2, 3, okay, just nice. Okay, so distribution factor, okay, distribution factor for NA because it is fixed and sini fixed. Okay, sini fixed. D is also fixed. Is also fixed. Fixed kat sini. Okay, fixed distribution factor 0. So both and fixed, the factor is 0. So now we should calculate the remaining. We should calculate the remaining. Okay, we should calculate the remaining. Okay, for BA, for BA, okay, for BA, so yang ni saya tambah satu lagi. Bukan. Okay, sini join sini join. Join, so yang ni lah tadi join B. Join B. Ni join, yang ni join C. So this is join C. Join. Okay, ni member lah. Member representing 6 member and moment. Okay, so yang ni. Okay, so yang ni buat menu aja, cuma saya nak tunjuk dengan you. So we can formulate it. We can set all the formula in Excel and we can do it easily. Okay, So K for BAB is 0.333. Total means 0.333 plus 0.333. Total at joint B. Total at joint B come from this, okay, and come from this. Total join B tu from BA and from BC. So that's why to calculate distribution factor, it is 0.333 divided by total. Total must come from 0.333 plus 0.333 come from BC. So we get 0.5. 0.5. So if we want to calculate using the same formula again, from BC we use 0.333 divide by total. Total K total. Yang ni plus, okay, we get 0.5. Or if we use 1 minus 0.5, also we get the same. So we continue to calculate K, not K, DF for CB. DF for CB is 0.333 divide by total. Total C means from CB from CD. Okay, from CB we get 0.333 divide plus, okay, from CD we get this. 0.4. So again, it is 0.5 divided by total 0.833. Okay, it is 0.5 divided by 0.833. Okay, formula dia 0.5 divided by 0.833. We get 0.6. 0.6. Okay, 0.6. So yang ni distribution factor. Distribution factor. Formula apa? Formula tadi itulah K divide by total K. K divide by total K. And then for, okay, refer back to this. Okay, now we want to calculate fixed end moment. Fixed end moment. Fixed end moment, basically we only calculate value for member with loading. Means that for AB, there will be no fixed end moment. Zero lah kat situ. And zero value, we don't need to write zero in the table. Okay, so kita leave as blank. Okay, so we move to member BC, member CD. Member BC, member CD, fixed end moment. Fixed end moment ni lah yang tadi yang saya explain, dia punya sign convention tu kan. Sign convention ni. Okay, yang ni boleh tengok lah in detail, in the slide tu kan dia dah tunjuk jugalah, the one that I have shown to you in Excel. So dia punya proses, dia punya value, you boleh check balik. Okay, so we get the same lah. We get the same. Okay, move to fixed end moment. This is fixed end moment. Okay, fixed end moment, boleh nampak tak? Okay, fixed end moment. So we just need to refer to the formula. So to the formula. So formula for member AB, since it is subjected to UDL along the member. So formula we use is WL squared over 12. WL squared over 12. WL squared over 12. One negative, one positive because of the behavior. This is counterclockwise. This is clockwise. That's why one negative, one positive. One negative, one positive. Okay, for member CD, for member CD, it is P subjected at the center. We use this formula. Okay, again direction, same direction. Okay, one negative, one positive. Formula is like this. Okay, so I want to calculate also this value in Excel. In this Excel. Okay, so fixed end moment. Fixed end moment. Fixed end moment. There is no fixed end moment for ABBA, 0. So we move to BC and CB. BC and CB, one negative, one positive. BC negative, CB positive. So it is negative because of the behavior. It is WL squared over 12. W is W apa? 20 dengan 12 ya. 20 dengan 12. Okay, this is 20 L squared over 12. WS squared, WL squared over 12. So we get negative 240. So another one must be opposite. Another one must be opposite because condition of FEM must be like this. Okay, and then PL over 8 for the formula. Refer formula from the formula. So PL over 8, Masya Allah, kejap. Okay, so it is 250 P, L is 8, P is 250. So it is PL over 8. PL over 8. So PL over 8, so we get, okay, we get back 250, right? So it is negative P, P is 250. 250. 250 L over 8. So dapat 250 lah actually. 250, kalau formula PL over 8. Okay, so another one is positive. Okay, so compare with the answer. So we get here negative 240, positive 240. Yang ni. Negative, positive, and then negative, positive. Okay, negative 240, 240, negative 250, 250. Fixed end moment. So basically, DF and distribution factor, DF and fixed end moment ni straightforward lah, straightforward. So this is fixed end moment. Fixed end moment. Okay, now we want to start distribution. To start moment distribution. To start moment distribution, okay, dia proses dia macam ni. Okay, kena imagine diagram yang tadi tu. Diagram yang tadi. Diagram dia macam ni. Okay, it is like this, original, UDL and point load. UDL and point load. Okay, so if we draw it separately, means that member and join separately. So member, join. Member, join. Member, kan? So UDL ni, we get FEM negative 240 because of this loading. This is 240. Okay. And then we get another one here, 240 as well. And then we get 250 from point load. From point load we get, kan, from point load we get, this is 250, right? We get, here is 250. Here is also 250. Okay, this is fixed end moment. Okay, as the first member end moment in the table. Okay, remember that to distribute, we have to distribute joint moment. Remember that the joint moment opposite this member and moment. Jadi, so apa yang you nampak ni sekarang tadi untuk member kan? Okay, untuk member sekarang ni kita kena letak joint moment. Letak joint moment, so saya ambil font color biru. Okay, font color biru ni untuk draw joint moment. Means that kalau dekat 240 ni, dekat joint, sini joint dia kan? So, joint ni dia mesti opposite. Okay, dia ada lawan dia. Nilai dia 240. Okay, yang ni pula. Yang ni dia ada 240, 250. Okay, sama juga yang ni pun dia ada lawan dia. Sebab ada join dekat hujung ni. Dekat hujung ni ada join. Fix. Dekat hujung ni ada join. Okay, hujung ni ada join. Dia macam ni lah. Okay, yang ni dia kosong. Yang ni dia kosong lah. Dia macam ni only. Okay, so join moment for B. Join moment for B, sini lah B. Join moment for B yang ni. Join moment for C, sini C. Join moment for C yang ni. Okay, so the moment that we distribute is join moment. Okay, that's why. Okay, yang kita buat dalam table tu, yang mana? Yang dekat join tu. Yang dekat join. Join ni yang kita kena kali dengan distribution factor. Kali dengan distribution factor. Okay, kali dengan distribution factor. So, yang ni saya tunjuk ni dulu. Ni dia terus buat dalam table ni. Okay. So, dia kan proses distribution moment discuss in yang tadi tu. Dekat sini. Mana dia? Dekat sini proses dia tu. Okay. Tak apa. Kita tengok dalam tab, dalam Excel ni dulu. Okay. So, now kita akan start buat first distribution. Okay. So, label dalam Excel tu distribution. Label dalam Excel is distribution. Okay. Okay. Kat sini kan join B. This is join B. This is join C. Okay. So, join moment. Join moment means. Okay. Join moment means total ni. Representing by this diagram. Yang tadi. Diagram tadi. Mana diagram saya tadi tu? Sekejap. Yang ni. Okay. So, at B, join moment is 240. Sini kan, nilai dia 240. Okay, 240. Kita dapat from table. From table ni, kita dapat kat sini, in total, these two value, bila kita total, nampak tak? Sini 0. This is 0. This is, kat sini 0. Kat sini 0. Tapi 0 kita tak tulis dalam table kan? Okay, 0. So, it is 0, 0 plus dengan negative 240. Tapi dalam diagram tadi, dia positive 240. Sebab apa? Yang ni, yang the real thing happen is yang dalam box tu. Dekat join B. That is why dia 240 positive. Positive. Sebab this positive value yang kita nak distribute. Bukannya negatif yang kita dapat from sini. Bukan negatif ni. Ini bukan. Kita nak yang ini. Okay, yang ni. Yang dekat B, dekat join. Okay, that's why kita dapat dia 240. 240. So, cara dia kalau nak set dalam Excel ni. So, dia punya proses is okay, join moment times with distribution factor. The factor for BA is 0.5. So, it is negative to make it positive kan. So, total times with distribution factor. Distribution factor. Okay, time with distribution factor. Okay, it is 120. It is 120. Sama lah dengan sini. Sama dengan sini. Okay, ni. Okay, dalam table ni, dia 120. 120. Sebab apa? Sebab dekat sini, dia totalkan yang ni tukar sign. Kenapa tukar sign tu? Sebab join moment opposite with member and moment. So, 240 yang kita distribute bukan negative 240. 240 representing this. Okay, this 240. Yang ni nampak Nampak ni Boleh nampak kan? Boleh nampak tak yang ni? This 240.
Boleh.
Boleh.
Okay. So sama juga dekat C. At C. At C nanti kita akan distributekan total yang ni lah. Yang ni. Kita tengok table balik ya. Okay, yang ni. Okay, so yang ni belum habis lagi. So kita nak distribute. Okay, total moment. Join moment. Join moment dia 240 kali dengan distribution factor dia 0.5. Distribution factor for BC ya. For BC is 0.5. Okay, we get 120. We get 120. Empat value ni kan. Okay, in total must equal to 0. Empat tu in total must equal to 0. Barulah betul. Kalau ada value, salah. It must be equal to 0. Okay, so kita dapat like this. Like this. So we do the same for the next one. For C, for join C. Join C, total moment at join C. 240. Okay, total moment at join C we get from this. Okay, join moment is 10 or negative 10. Or negative 10. Totalkan dua-dua ni. Dapat apa? Dapat apa? Totalkan dua-dua ni.
Negative 10.
Negatif 10.
Negative 10 is it join moment? Cuba tengok yang ni. Join dia 10 or negative 10. Tengok yang dalam kotak tengah tu dekat join. Tengok dekat sini. Tengok dekat sini. 10 or negative 10 ni. At C. 10 or negative 10. 10 ke negative 10 yang ni? Yang ni.
10.
10. It is 10. You dapat negatif bila you tengok yang ni. That is not join moment. Join moment yang opposite dengan yang dua tu. So yang kita tengok yang dalam kotak yang saya dah highlight tu. Okay, it is 250. It is 250. 250 minus 240. So we get 10. 10 is join moment. 10 is join moment. So inside this table, okay, I put negative inside the table to represent join moment which is opposite with member and moment. So yang ni plus yang ni. Join moment is 10. Nampak tak? Join moment is 10. Join moment is 10. Yang ni kena kali dengan factor. Kali dengan factor, the factor is 0.4. The factor is 0.4. We get 4. 4. Okay, we get 4. Okay, again, join moment is 10. How we get 10? We get like this. Okay, join moment is 10. So this 10 times with distribution factor is 0.6. Distribution factor is 0.6. So, yang ni. It is equal to 6. And in total, these 4 values must equal to what? Dapat apa? 0. The concept is MB is equal to MBA plus MBC. MBC and it is equal to 0. Yang ni dalam slope deflection method. MC as well. MCB plus MCD. CD equal to 0. That's why total tu must be 0. Okay, so this is the first step dalam table. The first step dalam table. Okay, this is the first step dalam table. Tak sempat nak berkenalan, dah cukup 2 jam. Okay, tak apa. Kita jumpa balik esok. Esok kita buat sesi ta'aruf. Okay, so nanti tengok balik video yang tadi tu. And tengok juga yang ni, this is the first process bila kita nak start buat moment, nak calculate internal moment or member end moment. This is the first step, the first distribution. The first distribution. Okay? So if you have any more question, you can text me using Teams chat. Okay, using Teams chat, nanti saya akan answer you lah. Okay, if you want to do your exercise, any exercise, please put into the OneNote and I can check your answer. Okay, so photo session pun tak sempat dah pukul 10. Tak apa, kita bawa semua ke esok. InsyaAllah esok kita akan jumpa balik. Okay, so thank you very much. Thank you very much.
Okay.